Oxford Brookes University Engineering Projects BSc Mechanical Engineering Programme, Module Number U04692 by Paul Lancaster, 10072020. This presentation will take you along a path describing the steps required to create an Arduino-controlled DC motor controller. Project selection. The project objective. The guidelines say the resulting project should go substantially beyond the project work done in any of the taught modules and should enable students to consolidate their knowledge and strengthen skills acquired in taught modules. The project selection. Which project would fit all of these criteria for me? The motor speed controller. A project for a student interested in control engineering who has done module U04692 Control Technology. The object to design a controller which will be implemented in an Arduino board. Does it fit? Interested in control engineering? Yes. Completed U40620 Control Technology? Yes. Go substantially beyond the project work done in any of the taught modules? Yes. Learn about the Arduino board and the Atmel AVR microcontroller? Yes. Sounds like my kind of project. The outline of the project. Question. What does a motor speed controller do? The purpose of a motor speed controller is to take a signal representing the demanded speed and to drive a motor at that speed. The components. The electric motor. Red wire positive, black wire negative. The sliding potentiometer. Slide left and right to produce digital output in the range 0 to 1023. And the Arduino Uno, the brains of the outfit. The Arduino platform. The Arduino is an open source project designed to enable students to learn how to program microcontrollers. The Arduino used in this project is the Arduino Uno R3. This is a programmable platform for the Atmel ATmega328 microcontroller. The board has 6 analog pins, 12 digital I/O pins, a USB plug for loading machine code to the board, and a power supply and power pins. The Arduino platform. The Arduino is an open source project, the result of which is a programmable platform which allows people to learn how to program microcontrollers. The board is a programmable platform for the Atmel ATmega328 microcontroller. It contains 6 analog input pins to take button inputs, 12 digital output pins, a USB plug, and power supply and power pins. The Arduino development environment. Runs on a PC. The language is in a C and Java style syntax. It compiles and loads via the USB onto the Arduino. Pulse width modulation. This is a method of switching the current on and off at a very high frequency. The duty cycle is the amount of time the signal is in a high state as a percentage of the total time it takes to complete one cycle. In this diagram, the duty cycle is 50% of the cycle, so therefore it is on half of the time. The theoretical average voltage is the full voltage times the duty cycle, so therefore in this situation it's 5 volts and half the time is on, so the average voltage would be around 2.5 volts. How to generate PWM on the Arduino. It's quite simple. You read the analog value in from the analog pin, convert it into a value that the Arduino will understand, and write it out using an analog write to the digital pin. The process of generating a PWM is automatic. Build the circuit. A motor speed controller implemented in an Arduino board, a potentiometer at the top, the Arduino board, and a motor connected to it receiving PWM signals. Job done. Not quite. The Arduino works on 5 volts. I want to run a 12 volt electric motor, and that's not going to work. The 5 volts will make the motor run at less than half speed, and worse than that, the current draw will most probably burn out the Arduino. The H-bridge circuit. The H-bridge circuit are 4 MOSFETs used in a H shape. Opening and closing them in the correct sequence causes the motor to rotate in the desired direction. H-bridge operation. In the diagram on the left, MOSFET A and MOSFET D are closed, causing the motor to rotate clockwise. In the diagram on the right, MOSFET B and C are closed, causing the motor to rotate anti-clockwise. The MOSFET. A MOSFET is a metal oxide field effect transistor. In effect, it's just a switch. There are 4 different types. For this application, the N-type enhancement MOSFET was used. When a voltage is applied to the gate, current flows between the source and the drain. Shoot through and back EMF. In the diagram on the left, MOSFET A and MOSFET C are closed, creating a direct path from the supply to the ground. This is a short circuit caused by bad synchronization. On the right hand side, a motor is being driven and acting as a generator. As you can see, a 12 volt motor which is driving this motor is producing 10.21 volts, quite a considerable voltage. To avoid shoot-through, 2 PWM signals can be generated with a small gap between them, known as dead time. This way, there is no possibility of both being open at the same time. A gate driver. One of the problems with the MOSFETs for this circuit is that they require 12 volts to turn them on and off. However, the Arduino will only produce 5 volts. So therefore, a device has to be put in between to convert the 5 volt signal from the Arduino into a 12 volt signal that operate the power MOSFETs. The IR2101 is a dedicated MOSFET gate driver. A gate driver is a power amplifier that accepts a low power input from a controller IC and produces a high current drive input for the gate of a high power transistor such as a power MOSFET. Bring it all together. The circuit was designed in Proteus, a software emulation package that allows you to place the components onto a board and then run the circuit as though it existed physically. In this situation, we have an Arduino hooked up to a potentiometer connected to the gate driver, which in turn is connected to the MOSFET, which then powers the motor. The next step is to build the physical circuit. A breadboard is mounted onto an Arduino shield, which fits on top of the Arduino to ease the way you connect the things backwards and forwards. The black blob in the center, with IR in it, is the gate driver, and the 2 black objects to the right hand side are the MOSFETs. The sliding potentiometer is the red device with the yellow button on it. This is a demo of the system in operation. Conclusion. The Arduino is a capable device, and as demonstrated it can be used to control a 12 volt brushed electric motor. The weak link is the microcontroller that it uses. Other microcontrollers have dead time registers that can be easily set to create dead time. A better solution to this problem is to use a dedicated bespoke electric motor controller, that is built onto an Arduino shield. And here's one that was prepared earlier. Made by Infineon. The two large black lumps, they are half-bridge circuits. There's a large capacitor in the circuit because this device can handle 50 amps. Any questions? Well, there's no one here to answer questions, so I'll call that a done deal. Thanks very much for listening.